Hello and welcome. Sorry not to be there in person present. That was the original plan, but I had a last minute personal issue yesterday and I couldn't make the trip. We're going to talk today about licensing and free software licensing. So feel free to interrupt me at any time. I guess it's a bit weird to do a remote presentation, but these are the COVID times, so everything is a bit weird when we do any kind of events. Quick presentation about me. I'm a bit of a free software and an open source software license buff. When I say license, it's really the object of license and the detection. And I build tools to help detect these licenses, origin license of code. Weird fact about me, I signed off on one of the largest deletion of lines of code in a Linux kernel. But this was not really code. These were commands, and these were licensed commands. And trust me, it's a skill. I'm very good at it. I've deleted tens of thousands of lines of commands. And if you're not very good at it, you can actually crash the build of the kernel, weirdly enough. So that's a skill. I used to also to have over 60,000 GitHub forks. So I'm a kind of a code hoarder. But that's probably a professional bias. So that said, we're going to talk about software packages and their licensing, generally speaking, the domain of metadata. And it's a problem because we're reusing ever more packages. I help a lot of software teams figure out what's in their code. And compared to a few years ago, there's 10 to 100 more packages than there used to be. When I say packages, would be something like a Maven jar, a Node package, a Python package, and these kind of things. Or it could be a Debian or a Fedora package on the system side. So that's also because we can really build applications from components, and that's a dream of the 80s and the 90s that being realized thanks and because of free and open source software. Yet in the meantime, at the same time, it's a mess. I can see today commercial products. I recently looked at a fairly large application used for a part of a system that's used in a carrier on the back office systems. And it was composed of about 80 different Docker images, a total of 700 layers. And across all of these Docker images, there were about over 10,000 different package versions. And when you reach that kind of volume, this is a mess because you have pretty much everything in terms of origin license that's in there, different language, different technologies. And we need clarity, and there's absolutely zero clarity today. It's a messy bubble. I would hope clarity in licensing would be there too, and I try to work on that. I'm in the studio about a bit over a year ago now, on the 5,000 most popular open source software packages across command ecosystems. And less than 5% of this package had a documentation of the license that I would consider to be really complete and comprehensive, meaning there was a code at the metadata level in the package manifest that would declare the license. That could be a real code. That means something you can read with a machine. There would be license in all the files with notice, with something that would be non-ambiguous in terms of license. And these licenses will be well-known licenses, not exotic, less traveled ones, in particular reference at the SPDX project. And there was no discrepancy between the top-level manifest package and the file-level package. and 5% on the 5,000 most popular package, that's really problematic, meaning that eventually, even for this most popular package, you will need to do some kind of review. The other thing is that it's difficult to talk about software. No project, no application is an island today. You're not exclusively developing in Go or JavaScript or Python. You may end up using a bit of both, and each of them on any serious application or package, application or system. And the same package name at NPM called file may be completely different than the Linux file utility, which helps you look at file and MIME types. So this is a mess. That's where we are, and that's what I'm trying to fix. And the plan to fix this is going to be, first, we're going to look at, oh, there's a typo. It says the many, double repetition, sorry. So we're going to look at the many current ways we have license being documented across different package types or ecosystems. Look at the way things happen with copyrights, and then a bit of package manifest and their dependencies, but a bit less. That's not the primary focus there. And we're going to look at how we can define common languages about that to help fix the problem, and then how effectively we can have an action plan to review and fix all the licenses. So it's a big topic. So, I mean, license in some ways should be boring, and we shouldn't have too much to worry about. But if you think of it, there is no free and open source software without licenses. And what we're doing when we say this is open is defined because there are open licenses that support this being open from a formal and legal perspective, which is important because there's always a tendency to have half-baked open approach, something we could call open source or open washing, which are trying to use licenses that resemble or approaches that resemble the ways of free and open source software, but which are not really free and open, definitely not open. So license really are the foundation in some ways of what we're doing everywhere in free and open source software development. And the big advantage of free software license over proprietary license is it's not so much because this is open, but it's because there are a few and well-known terms. There's roughly a couple thousand licenses that may exist in the worldwide world in terms of free and open source software license. There's 10 to 20 which are commonly used. And if you compare and contrast that with proprietary software contract, every single contract will have likely special terms which are unique to this contract. So there's as many software licenses that there are contracts. So we are blessed to have such a small number of licenses, which allow us to eventually make the license a non-issue. If I say, oh, my software is Apache license, bang, I know what it means. I know where I'm going and what I can expect from the licensing of this project. Same thing with, if I say it's GPL, these are well-known, well-defined entities. Yet, unfortunately, it's still a mess because in as much I would love to have something that's clear and non-ambiguous, we're not yet there. So I'm going to go through a few, and I won't comment them all one by one, but just to give you a bit of an idea of how many different ways there exist in different package ecosystems. So these package ecosystems are most commonly tied to a programming language, not exclusively, but most of the time. And each of them has evolved separately. That's why it's a Babel mess. they've evolved their own language, which is okay. But they've also evolved their own ways to discuss about the name of their packages, the versions, and of course the licensing. And very often, frankly, licensing has been a bit of an afterthought. And is more often than not poorly specified, if not ambiguous. So let's start with Python, which is one of the language that I use the most. There's two license fields in the Python package manifest. One which is a free text field, and the other one which is a list of classifiers which has a bunch of codes for licenses, but also the status of a project or its domain. These are the Trove classifiers, which were originally designed as part of the SourceForge Alexandria platform. If there's any old timer around, these are essentially the same conventions, a bunch of tags. They're super ambiguous. So either free text is by definition ambiguous, but the classifiers themselves are ambiguous. For instance, there's one for the BSD license, which says BSD. The problem with the BSD license is that there's at least 4 different big clause and conditions in this license. And there's probably 20 or 30 variants, but not specifying whether it's a 2 clause, 3 clause, or 4 clause BSD is problematic because you don't know, and it has an impact on how you can comply. And if you don't know how to comply with the term of an open source package, that's problematic, right? You may not have the right to use them, or you may not agree with the terms and conditions based on your policy or organization or else. If I'm building GPL license code, I don't want to have proprietary code mixed in with my code. So it's important for me to know the license. And if I'm in a commercial proprietary setting, I want to know exactly what are the components and where they're coming from, what's the license. So Python, that's one. Ruby has a single license string field, or it can be a list. They recommend to use the SPDX license identifier, which is a list of about 500 license identifiers attached to a well-known text, but they don't really force and enforce it. And right off the bat, if you have either a list or string, what happens if you have a list? Do all the license apply, or can you pick one of these? That's not defined. Apache Maven use something called a POM, project object model file, which is an XML document, which has also a list, in this case of 3 or 4 elements. There's a list of license name, URLs, and comments. But there's no convention, nothing beyond just some common practice. There's no enforced convention of what you put in the name, URLs, and comments. And having a list of licenses doesn't tell you whether all the license apply or you can pick one or some apply. So that's also, again, ambiguous. You'll notice, by the way, that this idea to have either a string or a list is a recurring theme. And most of the time, unfortunately, what the list means is not specified. And it's important because you can have something like, say, a widely used JavaScript library called jQuery. jQuery, historical version of jQuery used to be licensed under a choice of the MIT or the GPL license. If you have a list which just says MIT GPL, you don't know whether it's both licenses that apply or you can choose one or the other. So that's a serious problem. CPAN also, by the way, use custom identifiers and their own custom IDs. And you have to understand that each time there's a custom list of identifiers, these are different for each of these package ecosystem. So eventually you end up having to have if you were to build mappings, a giant matrix which maps all the license to a normalized code. Debian is interesting because they probably have the most comprehensive way to document the package licensing. It's also fairly complex at some level. So they have a file format called the Debian machine readable copyright file, originally called DEP5, DEP5, Debian Enhancement Proposal number 5, which is a structured parsable file, except that not all the packages, even in the most recent version of the package and the most common package, use this format for documenting licenses. And it's also, in the end, even though it's structured, parsable, and supposed to be formally defined, in practice, it's not so easy to make sense of in a machine-readable way after all. They use a few command IDs for 5 or 6 different, the most common license, like the GPL, LGPL, and Apache. And otherwise, these are custom IDs which are defined at the level of a copyright file. So it's very hard to make sense of it globally. It took me and a buddy about 3 months worth of work to build a decent parser to make sense of this file, just to give you an idea. And that's a lot of work. Fedora use their own license IDs, and they're using also, sorry, not license, another typo, not a license, but license file tag in RPMs. In contrast with the very detailed level of licensing information that may exist in Debian, Fedora is much more practical and it's much simpler summary. There's less complexities to parse this. But they're using their own ID, and each time you have your own set of IDs, that means you've essentially created a new language. We'll come back to that in a second. So NPM is the Node Package Manager, which is used mostly for JavaScript. Is using SPDX license expressions with custom extension for certain IDs, which makes it a bit complex. Or it can be a list, or it can be an object. I've seen also in some case older version that we're using list of objects. So all of a sudden, if you have a list, a string, or a mapping kind of object, JSON object, that starts to be always problematic. All right. I won't comment on each of these going forward, but one which is interesting would be R and CRAN, which is the Comprehensive R Archive Network. So the R language is statistical and is oriented towards statistics and math. And it's funny how the ethos of a given package ecosystem actually transpire down to the way they do deal with licenses. They have a way to express things with mathematical notation down to the version of a license, in this case, saying it's an LGPL, which has to be superior or equal to version 2, but inferior to version 3, which means basically LGPL 2.0 or LGPL 2.1, because there's unlikely to be any other LGPL in the future. But I find it funny in a way that they end up, their interest for math and stats transpires down to the notation they use for licenses. Another one which is interesting, where Android uses empty tag files to provide a class of license. So literally, you may have inside one component or one app or one repo used in Android, a file called module_license_BSD_Apache_GPL, which is empty. And then it has to be accompanied with a notice file, and the build system roll that back in the long notices that you can see if you have an Android phone, if you go to the settings. So, as you can see, there's everything under the sun. Some use SPDX IDs, files, recommend using this, but don't enforce it. Or in the case of Go, there's absolutely zero license metadata. In a way, it's not a bad idea, because rather than to pile on the mess, having no license and leaving that to other ways to detect the license is not the worst idea. There's also weird stuff. So I've been involved with, as I said, fixing the licensing the Linux kernel. And when we started, there were over 600 ways to write this file is under the GPL. And you could wonder, how come there's so many ways to set that single thing? Well, that was it. So it was really messy. You could see very terse way, like we have at the bottom, GPL. And I don't pick on Red Hat there, it just happened that it was the most terse license statement we could find, which is literally 4 letters and an apostrophe. Or in some case, witty and funny, where you had code under the terms of the GPL in the Linux thermal drivers. I've seen elsewhere outside of the kernel, people that were GPL shy and that were mentioning or stating their license for a module license for the loadable kernel module that you can load in the Linux kernel, which is a way to extend the kernel. And rather than saying GPL v2, which the kernel would expect as a license can make sense of, it would be written down in using ASCII code and actually hexadecimal ASCII code. And the compiler doesn't make the difference to a compiler. GPL v2 and 4754C20 blah 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 is exactly the same. So at runtime doesn't make a difference, but of course to a human, that's quite different. So that's licensing. So licensing is a mess. What about copyright? There's only so many ways you could write a copyright notice. Well, actually, no, it's also a mess. Every single permutation of a copyright word or sign, a name or a list of names and dates, every permutation you could think of, somebody came with them and mixed these all in all possible ways. The solution I came with was eventually to write a natural language parser and a grammar with, as a total, close to 2,000 different lexing and parsing rules. And the problem is mostly solved. It's being used day in, day out by a lot of other tools that depend on this ability to detect copyright. But it's much more engaged than the first reaction of many, which would say, oh, let me write or find a regular expression and be done with copyright. Now, versioning. Versioning is important for two things. In the world of software packages, you use versions to attach a version to a package, but also to resolve dependencies. So for instance, to say, I need this package with this version or any later version, but not this other version. It's also important for vulnerabilities, where typically you will use a compact notation and refer to a range or either a notation or a statement saying, hey, this version and all the version before this version of my package are affected by a vulnerability. And we would hope that version numbers would be really boring and it wouldn't be something we would have to discuss. Yet, again, each ecosystem has its own ways to assign a meaning to the versions. For instance, RPM used something called Nevra the name, epoch, version, release architecture, and Debian packages use something similar, but in the details, subtly different in a way that is not compatible. And they use typically a notation to say, hey, this version is superior or inferior or equal, or should be inferior. So I depend on something which should be superior, inferior, or equal to this version. Yet, not two of these notation give the exact same meaning. So sometimes you have two superior signs used by Debian. You have a double pipe notation used in NPM, Node, Semver, and so on. And on top of that, every package dependency ends up being resolved differently in each ecosystem. Go, for instance, will prefer taking the oldest compatible version. Some would take, in some cases, a random version. Many would prefer the latest version. So there are strategies to resolve dependencies in the dependency graph, which end up being eventually arbitrarily complex and complicated. Now, if you cannot talk about version, license, package names, and copyrights in a common way, automation is become super hard, right? It's hard already, but if you don't have a way to have the same language, it's even harder and nearly impossible. So we need to fix this mess. And for that, we need new standards. And you could say, oh, all right, it's the classical thing. We need new standards. We're going to have one more competing standards. In practice, this is not so true if you have a certain approach to building standards. And if you focus on building common languages and building names, and naming is difficult, but if you can build common names, then you're not really so much building a standard in as much as enabling a conversation and a language, which is something we are blessed to be able to do in computer building languages. And in part, I've been enthused by the success of a small specification I started called package URL, which is emerging today as a de facto standard to reference package across package ecosystems in a way that's the same whether you talk about a Docker image, a Python package, or a Debian package, which has been embraced, especially in the world of security, as a modern way to reference packages and potentially an alternative or complementary way to reference package for vulnerabilities at the National Vulnerability Database in the future. It's under consideration by the NTIA and several efforts in the space of what's loosely called software bill of material. So license, we have SPDX license ID and the problem is mostly solved. So that's a good thing for a start. And I also maintain a database of license beyond SPDX, but using SPDX identifiers. And we have roughly about 1,700 of these, so about 1,000 more than SPDX. So that's also a way to provide this kind of standardization and common language. Software package, we talked about package URLs. Version range, I'm just started to work on a new mini spec that will be complementary to package URLs to have a unified notation, something super simple, but a unified notation for version range, such that when you say this package version should be superior or equal to this package version, there's no 5-way to express that, but just one. When it comes to vulnerabilities, the National Vulnerability Database in the US, which is maintained by the NTIA and the Commerce Department, use something called CV, Common Vulnerability Enumeration, which is a code assigned to a vulnerability. So that's working pretty well. And beside that, there's really a 3-letter acronym plus a number And there's a zoo of these which have emerged, which make it that there's mostly a lingua franca on how we can talk about vulnerabilities, and everything ends up in the end using a CVE ID when these are being assigned centrally. So that's mostly solved. And the last thing is when you reference a version control system. So when you have source code, which is stored inside, say, Git or Subversion or whatever will come next, the ability to reference a given repository and a given version of the code inside the repository and a given path in a common way across version control systems is something also that's mostly solved. All right, so we're almost there. How to fix all the licenses? I think the essential thing is to be able to push this information upstream on each of the package author and project maintainers and help them get this information correct. In the end, it's a win-win-win for everyone. If the license is clear, it's easier for contributors and aspiring contributors to adhere to the license term. It's easier for the users to make sure they can checkmark the license and consider that a done deal. And everyone can focus on the things we love. That means code as opposed to licenses. Well, I love licenses, but everyone else prefers code mostly. So it's a multi-pronged strategy. The first thing is to have a good tool to detect license. And ScanCode Toolkit, which I maintain, has become the quasi de facto industry standard tool in the space, which is used by most everyone and is super accurate. Is being heavily maintained and evolving quickly. And it's really the standard in that space. You can think of it as a universal translator. It's able to make sense of the license convention that exists in all these different package management environments we talked about, for instance, and normalize them using SPDX outputs. You could think of it also as a license and copyright linter, because if ScanCode cannot understand your license copyright, you probably have something weird. And trust me, there's still a lot of weirdness out there. So equipped with such a tool, the second step is to scan all the code, review the scans, and eventually contribute to the project upstream a way to update the documentation, essentially, which is a huge amount of work. And it's not easy to scale up. I'm a co-founder of a project that tried to do some work there, but does not done much on upstreaming, which is called Clearly Defined. And it's not scaling up at the moment. So we need a different approach. There's some maybe help down with machine learning to help spot inconsistency in licensing. So we built a small tool that may help there. And as an adjunct to help human pinpoint areas where their smarts are needed. And another thing is to have leverage. Leverage means rather than fixing the licenses one by one, is working with a whole ecosystem at once. For instance, I'm working these days with the Python community. I've been a bit late in delivering this, but the idea is to just very simply adopt SPDX IDs in Python package manifest, which means the mere fact to adopt a common language and convention and SPDX license expressions means that license becomes non-issue. And last but not least, I'm trying these days to organize campaigns to really mobilize the whole community in a given ecosystem to do massive improvement campaigns. And I want to start that with distro packages first, because you have a wide variety of packages which are being used, and it's going to trickle down across the spectrum of open source projects. the effort I was talking about on Linux, we see this effort of normalizing the license documentation, the kernel, trickling down to all kind of project now across the board. So that's, I think there's a leverage effect that's going to be really important there. And the last thing is also making sure that we can open all the data, because more often than not, there's a lot of companies in that space, and that's great. And to keep the data locked in. So it's great to have tools, but you also want to have not only open tools, but also open data. And so we are building something called vulnerable code to open all the vulnerabilities about open source package. And it's like you don't want to have a tax on open source package vulnerabilities. Like it should be free, like oxygen. That's what we're doing here. We're building this license database of all the licenses, and next we'll be working on a database of all the packages. But eventually, in the end, the idea to have database is important in the short term, but probably flawed thinking in the long term, where if the information would be upstreamed, and that was the information before, and available in decentralized fashion in a structured way across the board, then database become just a mere caching mechanism from information that's otherwise available. And that's it. That's how I conclude this presentation. So thank you very much. If you have questions, I think that would be great to discuss this now. See a few names in the participants that I know at least. So I'm sure some of you have questions. Please. All right. So there's a weird echo. Okay, I guess at that stage I'm going to stop sharing and look at the chat. Oh, I can't hear you. Oh. So the sound has been terribly bad? Okay, good. All right. So it's just because I'm getting some echo right now. And the echo is terrible. Okay. All right then. If there's any question in the chat. I'll wait a minute or two. So there's a question. Have any organization tried create a standard? So I'm very suspicious of organization that creates standards. I'm rather a proponent of trying to have something that works and that becomes a de facto standard that works because it's being used by tools. and then can eventually become a standard that's widely accepted. I've seen many specifications done by committee, which take forever to complete. And I'm going to paste the link to the package URL spec, which is something I'm really super proud of, which is a place where we have discussion in a fairly loose governance. So I've just pasted that in the chat. And you can see the pull request where you have many folks that are participating from lately. There's been a lot of discussion about OCI container images and how we can represent a package URL for these. And you have folks that, I mean, it's very humbling because it's really a who's who of everybody in the software space that's been participating there. And so I'm very proud of that. Now, it's been started in 2017. It's not a standard body. It's not a standard organization. It's just a grassroots efforts of a few interested and willing software developers and open source software developers that saw the same problem and try to solve it together. I don't think the de jure approach in this case works so well. It doesn't work too well, especially when you end up having standards that end up behind a paywall at ISO. The ISO, a good example would be software IDs in this domain, SWID, SWID, which is behind a paywall, therefore not accessible to open source developers readily. Even something like PDF nowadays is a problem for open source developers because the latest spec, PDF 2.0, is at the ISO behind the paywall. And I'm sure you can find bootleg copy, but I help on a PDF parser, which is popular in the Python world. And this is a problem, you know, paying 170 euros or dollars for a spec for each of the developers. So that's my position on specs. I think they're important, but people tend to be too attached to de jure standards, which have not been proven. Working bottom up, grassroots, focusing on working software first has been, to me, much more effective, efficient, and much more pleasant at the same way. You end up with shorter specs, and they're actually actionable because they've been evolving from actual usage in real code. I hope that makes sense, Jay Whitman. Okay. Yeah. And that doesn't mean we don't like standards and bodies. For instance, package URLs are going to be registered as an official URI scheme at YANA. And I probably intend after a while to do the same for the version range specification. But there's no rush. It has to come in due time when the wine is ready, you know. It's not, I think it was an old advertising from Gallo in the US. It says the wine is ready when it's time, not before. All right, any other question? Okido. Well, thank you very much for your time. I'm sorry I was not able to join and be there in person, but I hope this was useful. I don't know where I can post the slides, but I will post them. I'll ask the organizer where this can be posted. And if you want to have a copy of these slides in LibreOffice format. Thank you very much and have a wonderful day, wonderful evening, wonderful night. Bye now.